Hey, what's up, y'all? Thanks so much for joining me on today's video, Three Shapes, Four Colors, and Introduction to Processing, where we are going to learn how to draw this beautiful picture behind me using code. So for our intents and purposes, code is basically just a set of really detailed and specific instructions that we're going to give to our computers, and processing is the language that we're going to do that with. So to get started, let's head over to processing.org, and as you can see here, processing is a flexible software sketchbook and a language for learning how to code, right? So since 2001, processing has promoted software literacy within the visual arts and visual literacy within technology. There are tens of thousands of students, artists, designers, researchers, and hobbyists who use processing for learning and prototyping. And you've also got people like me who use it to make fully fledged projects. When you're just getting to know processing, I would definitely recommend spending a lot of time here in this part of the website looking at tutorials and examples. And as you get more familiar with it and start to make your own pieces of art with code, you're definitely going to find yourself spending a lot of time here in the reference part of the website, which is a really useful place to visit. I'm here all the time. It's basically like a little Wikipedia for all the stuff that you can find in processing. So you can click on a topic and it will have a detailed description, it'll have some examples, and then it has this nifty like related feature. You can look at things that are related to the topic that you're reading about. Of course, to actually use processing, we need to go here to the download part of the website and download the IDE, or Interactive Developer Environment, for processing, and it'll automatically detect your operating system, but if you need it for a different one or you have different hardware specifications, you can grab the right version. So once you've got that, go ahead and fire up the IDE, and you will see that processing is going to automatically make a new sketch for you, which is just what programs are called in the processing environment. And it's going to look like this, right? So let's take a look at the IDE. This main window, this main area here that looks a little bit like a word processor, is just where you're going to write all of your code, right? So you might write something like hello world. Oh, you probably want to spell it right too, right? Hello world. Now you can see if I break any syntax rules, this IDE is going to let me know in a few different places. Of course, we're going to get a little squiggly line under the bad syntax. There's a little red line over here on the right side. We've got a little message under the text area. And if we go over to this errors tab, you can see there's a little bit more of a detailed readout on the syntax error that we've made. Now you might be thinking like, geez, I get it. Like, why do you have to tell me 4 times I made this mistake? And the IDE is just warning you about this because syntax is really important in processing, and as well as many other coding languages, right? And so, processing won't even actually let you run your sketch at all if there's any syntax errors. You can see if I come up here to the run button to try and run this code, it's not going to let me. It's just going to say, hey, in here in the console, right, it's outputting this message. It's saying, hey, you've got an error. You can't run this code, right? So let's say I change it to something that doesn't break any syntax rules. And you can see I've made sure there are no spelling errors, there are no punctuation errors, and there are no capitalization errors in my code now. So these error messages went away. This one is just left over from when I tried to run it earlier. So if I come up here and press the run button, you'll see it does in fact let me run my code this time. A little sketch window will appear, and then you see it prints out hello world to the console, and that's because I'm using this function called print line. That's a really useful function to kind of output stuff here to the console. So you'll see we'll use that a little bit more in the future. Now that you're a little familiar with the IDE, let's take a look at the 2 main loops that every processing sketch is built on: setup and draw. So to create those, all we have to do is write void setup and then void draw, like this, with the parentheses and open and close curly brackets. And now I'm just going to press Command T. That's going to automatically format my code. Now, everything that I write in between these curly brackets, so all the code that's inside of my setup loop, right? Code here runs once, and it runs 1 time when I press this run button and I start my program, right? Everything that I write in between of these curly brackets, right, that belong to my draw loop, code here is going to run 60 times per second, right, given that your frame rate does not dip below that. So again, let's just review that. When I press play, the compiler, which is the part of this IDE that is going to read all of these instructions and interpret them for the computer, is going to first look at, okay, here's my setup loop. It's going to look at any instructions, any code I've written here, do that one time. When it gets to the end, it'll exit the setup loop here, it'll enter this draw loop, and then it'll run all of this code here, and when it gets to the end, it'll go right back to the beginning and do it again, and again, and again, until you exit your program, right? You've probably also noticed at this point that these lines here turned gray, and that's because I made them comments, and I did that by putting 2 forward slashes in front of them, right? And anything that's a comment, right, the compiler knows to ignore when you go to actually run your program. So anything that I put with 2 forward slashes, I can put any kind of nonsense, and I will not get a syntax error, right, because the compiler doesn't care. It's going to ignore this, right? Now, you can also use the command / to take things in and out of comment, which will be really useful later on when you're kind of testing stuff and you just want to take things in and out to see if things are working or not. And you can also use this syntax to write comments / ***/, and then anything that you put inside between those 2 slashes and stars, right, is going to be treated like a comment. Okay, so now that you're kind of familiar with these 2 main loops, let's take a look at what we need to put inside of them to actually start drawing, right? So the first thing we need to do is tell processing how big of a window do we actually want to draw things to. So we can come in here and say something like size, and then we're going to use pixels. So we'll define the width and the height in pixels using the size function here. It'll look like this. You got to punctuate it with a semicolon. And now if I press Command R, the keyboard shortcut to run my sketch, I should get a nice blank window that is 640 by 480 pixels. Let's say that I want to make the background of my sketch white. So I can use the background function, and we need a grayscale color value between 0 and 255. So I'm going to color it white, which means I'm going to use 255. If I wanted my background to be black, then I would come in here and instead of writing 255, I would write 0. And if I wanted it to be some shade of gray in between, I would pick a value in between 0 and 255. Cool. All right, so let's leave this white for now and start looking at how we are going to draw some shapes in our sketch. Now, before we do that, let's go ahead and take a look at something that is very important to know about processing's coordinate system, right? Most of us are probably used to a Cartesian coordinate system where the origin is in the middle. We learned about this in our middle school geometry classes, right? When x values get greater, right, then you're going to go to the right of the origin. As x values decrease, you'll go to the left of the origin. As you increase your y values, you go above the origin. And as you decrease your y values, you go below the origin, right? Pretty familiar. In processing, it's a little bit different. The origin is actually at the top left corner of the coordinate system, and as you increase your x values, you go to the right of the origin, and as you increase your y values, you're going to go down below the origin, right? So if you go this way, you're actually in negative x value territory off screen here, and negative y value territory up here, again off screen. Okay, so now that we know how the coordinate system works in processing, we can take a look at a very simple function that we can use to draw an ellipse, right? And in processing, what it's going to look like is we're just going to write the word ellipse. We'll open a parentheses. We're going to need to tell this function where we want to put the ellipse, and so it needs an x and a y coordinate. And then we also got to tell it how wide and how tall we want it to be, right? So if I were going to draw it here and I wanted to say, let's draw it in the middle of this little grid here, I need to go over 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4, and that's going to be the very center of this grid. So my code would look like this, 4, 4, right? And let's say I want it to be 2 units wide and 4 units tall, so I can say 2, 4, and then punctuate. And that's going to draw me something that looks kind of like this. Okay, so let's take a look at how we put that into here. Now, obviously our canvas that we've created is much larger than 8 by 8, right? So if I want it to be in the middle of the screen, and let me make a comment. So draw an ellipse in the screen, so we kind of keep track of what we're doing, right? So if I want it to be in the middle of the screen, I need to divide 640 by 2. I'll get 320, and 480 divided by 2 is 240. And then let's make it like 100 pixels wide and 300 pixels tall. Close the parentheses, punctuate with the semicolon, and Command R to see what that looks like. Okay, awesome. This is looking exactly like we expected it to, right? And this is going to work as long as we never change the resolution of our sketch, right? But what if I wanted to, for example, make this bigger and have my sketch be full screen, right? You're going to see in a moment that this now kind of messes up our code. My ellipse is still going to get drawn at 320 pixels by 240 pixels, right? If I go over 320 and down 240, but that's no longer the center of the screen, right? Because my display window is now much larger. This monitor, I think, is 1280 by 720, right? Fortunately, processing has a couple of built-in variables that are going to help us solve this issue, right? Variables are just like little containers for data. We'll talk a little bit more in depth about that later. But for now, we're going to use two variables called width and height. And these variables just return the width and the height of the display window, right? So if I go back to our original size here, let's get rid of this. And let's use that print line function again. And I can just print width, comma, height, right? And you see these turn pink. That lets you know that these are the special included variables that come with processing. And so basically, I'm expecting 640 and 480 to get printed out here in the console, right? Okay, great. So this is exactly what I want, right? Now, instead of actually writing 320 and hard coding this value, I can come in here and I can say width divided by 2 because I knew that I wanted to be right in the middle of the screen, right? 640 divided by 2 is 320. So if I go from 0 over here, that's 320, right? That'll be the middle of my x-axis. And then if I want to come over here and I want to move to the middle of the screen on my y-axis, I can take height, which I know is 480, right? And divided by 2, that should give me 240. So if I start at 0 and I come 240 pixels down, this is going to be 240, right? And so now I'm basically saying the same thing. Width divided by 2, 640 divided by 2 is 320, and 480 height, right, divided by 2 is 240. But instead of writing those actual numbers, I expressed it using these variables. So now, let's run this one more time just so we can see that it's going to look exactly the same. If I come back and I write my full screen function again, right? Okay, this is still working. When I run it this way, you'll see that this is working as intended, right? So now I'm able to always draw this ellipse right in the middle of the screen, no matter what my resolution is. And if you're working in a fixed resolution, you know what it's going to be, then you might decide, okay, I don't want to use these variables. But we're going to use these a little bit more today, and it's definitely going to be useful for you in the future. So I'd recommend just kind of getting used to thinking about position in terms of the width and the height of your screen. Okay, so let's go back now to our pen and paper over here and look at how the rect function works so that we can draw some rectangles. It's actually very similar to our ellipse function, right? It needs x, y, width, and height. So if we put all the same things in our rect function, 4, 4, 2, 4, right? Processing is going to go over here 4, down 4, right? And it's going to start at this middle point here, but instead of behaving this way like the ellipse did, it's going to draw the rectangle starting from the top left corner. So it's going to go 2 units out this way, 4 units out down, 2 units this way, and then 4 units up, right? So it's going to draw the rectangle this way. If we wanted our rect to actually end up looking more like this ellipse, right, or behaving more like this ellipse function, we need to call another function before the rect function, which is called rect mode. So I would say something like rect mode, and then center, right? And that will make it so that when I use this rect function, it draws the rectangles from the middle, puts that xy coordinate in the middle of the shape instead of at the top left corner. And then I can write rect 4, 4, 2, 4. Right? So if I write rect mode center, it will still go to the middle, right? It'll go to this position 4, 4, but it will now behave like the ellipse did and just draw a rectangle that is 2 units wide, right, and 4 units tall. It'll end up looking like this, right? Okay, so let's see how that works in our code. And you know what? I want to draw my rectangle on the left side of the screen. So I'm just going to put it before my ellipse so that I kind of keep that thinking left to right here. So we'll write rect, and then let's do, how about 1/5 of the screen? So width divided by 5, and then height divided by 2. And let's keep the same dimensions, 100 by 300. We'll run this. Let's see what we get. Okay, so you can see we're at 1/5 of the screen. We've got our ellipse still in the middle. And like I was mentioning before, right, it's starting at the top left corner and coming over and down and back up and drawing it 100 pixels wide by 300 pixels tall. Let's go back to this as well. And I do actually want it to behave like my ellipse function. So I'm going to say rect mode center, run the sketch again, see what that looks like. Okay, very cool. Now this is looking a little bit like our example. Let's go ahead and think about how we would draw a triangle on the right side of the screen. So to do that, we are going to use the triangle function. Yes, you guessed it. Triangle, right? This one actually needs a few more arguments. It needs 6 arguments, right? X, Y, X, Y, X, and Y, right? So you need an X and a Y coordinate for each of the 3 points of a triangle, right? And there's a couple ways you can do this. I could, define what they are. I could be explicit about this. And, if I were doing it on this grid, I might say, okay, I want my first point to be here, and I want my other points to be like here and here, right? And that will draw a triangle that looks like this. And so if I were to write all of that out, I would write, what is this first one? 4, 2, right? And then this next one is 5, 6. And then this last one is 3, 6, right? And that will get me this triangle that will look just like this, right? But it will kind of run into the same issue that we were running into with changing the resolution and that kind of thing. So we're going to do a little bit of math actually to figure out where the X and the Y positions are. Also, when I'm looking at that other canvas, it's a little bit harder to just, eyeball and say, oh, where should I put this, top point, and where does this other one go, and where does this other one go? So doing a little bit of math will make it easier, and I won't have to go and actually figure out what's this one, and what's this one, right? So what we can do is we know that the height of the shape itself, right? If we take that, the height of this shape, and we subtract it from the total height, right? So height, which is this area here, minus the height of the shape, is going to leave me with all of this area here, right? So I subtract all of this from the height. It's going to leave me with that. Well, I need to know what the Y position is of this point. And so I'm actually just going to take all of this colored in area, right, and divide it by 2. And in processing, we will need to put parentheses around this first expression because it does, I think, first the multiplication and division, and then it will do addition and subtraction. So it has an order of operations, right? And so we need to make sure that we put this subtraction operation in parentheses so that we're actually doing the math correctly here, right? And that'll give us the Y position, right, of this little point here. And as you can see, right, this expression here, height minus the height of the shape divided by 2, gives us this. If we just take this whole area here and we subtract it from height, we'll get the Y position of these little shapes as well, right? So we know that the first little y position that we need for our first point up here is height minus h, or the height of the shape, right, divided by 2. And then the second set of y coordinates will just be height minus the height of the shape divided by 2, right? And we're going to actually just subtract all of that from height. I did not leave myself enough room. Height minus this expression, right? And that will give us the second set of y coordinates here. For our x coordinates, what we can do is we can just say, I want to start at the same place, whatever I set my first x coordinate to. So x, our x naught, maybe our first x coordinate, we can just add whatever the width of the shape is by 2, and that'll go over, right, by that amount. And then I can just subtract the width of my shape, right, divided by 2, and that'll give me this area over here. So let's look at how we can put all of that into processing. And maybe actually what we'll do is we'll draw the points first. So let's say I want to put this one on the right side of the screen. So let's say 4 times width divided by 5. That's my first x position, right? And as we were talking about a moment ago, to find that first y position, we are going to say height minus, what is the height of our shapes? It is 100, no, it's 300, right? Height minus 300 divided by 2, right? And oh, I need, let's make it like 10 by 10. Let's see what that looks like. Okay, so that's that first point, right? For the second point, actually, I'll just copy and paste this. We want to take that x value, right? And we're gonna let's go to the right, and we need to add the width of the shape, which is 100, right? Divided by 2. So I can either write 100 divided by 2, or in this case, I'll just write plus 50, right? And then the y position of that one is going to be height minus the height minus 300 divided by 2. Let's see what that looks like. Okay, there's our second point, right? And then we do the same thing, but instead we subtract the width of our shape, half of the width of our shape, and we do the same thing here. Then we should get that third point that we'll need for our triangle function. Okay, so there's the 3 points of our triangle, right? So now I can come in here, say triangle, and I can just copy and paste these points, right? There's the first point, here's our second point, and here is the third point. Close that with a parenthesis and punctuate with a semicolon, and let's see what happens. Awesome. Okay, so this is our triangle, and we don't need these anymore, so I will just delete them. Excellent. So now we've got 3 shapes. Let's move on to figuring out how we're going to get 4 colors into this sketch. Let's go back to the background and take a look at using RGB values to set the color of the background. So the default color mode that processing uses is RGB, which stands for red, green, and blue. Right now, we're just using one argument, which processing interprets as a grayscale color value, again, going from 0 to 255. But if we add 2 more arguments here, then it now has 3 color channels, right? Red, green, and blue, and will, output the color, right? So this should turn red, right? This is all red, maximum red, no green, and no blue. So if I run my sketch, I should have a red background. There we go. If I want yellow, I can max out my green. Bam. Okay, now we have a yellow background. You might be thinking, gosh, this is cool, but do I really have to memorize like a bunch of different RGB values? Fortunately, you do not. Processing has this really neat little color selector tool, so you can come up here and, let's say I want like a nice like sky blue color for the background. I might come over here and, using these 2 things to slide around, I can find the color that I want, and then I can just copy these values, 57, 194, 255. 57, 294, 155. And let's run this sketch and see what we get. Okay, and so I definitely copied something wrong. 255 and 194, no wonder. Okay, now it's behaving like we were intending. So this is RGB colors. We're going to keep it simple for this tutorial. So let's just go back to yellow. And let's look at how we can set the colors of our shapes now, right? So these outlines, if we want them to change color, we can use the stroke function, right? So we'll write stroke, and then let's say I want my outline to be red, 255, 0, 0. And when I run my sketch, you'll see the outlines turn red, right? And it might be kind of hard to see, right? So if you want a little bit of a thicker outline, you can say stroke weight. Let's say like 5, but the default value is 1. Yeah, this is a little bit easier to see, right? If you don't want there to be an outline, instead of writing these things, you can write no stroke. All right, and so now you can see there's no outline. To change the middle of the shape, the interior fill here, we're going to use the fill command. Fill. So let's say I wanted my fill to be 255. I wanted that to be red. As you can see, now I've got a red fill for all of my shapes. You can also use no fill if you don't want there to be any fill at all. And you saw earlier the default fill color was white, and when I turn that off, then you should be able to see through to the background, right? So you've got the stroke here, but you can see through the shapes. And this can be kind of fun once you start to have more shapes on screen. You might overlap them, and you'll be able to see, through whatever shape is on top of the previous one, right? Speaking of which, in this sketch that we've made here, the rectangle is technically on the bottom, the ellipse is on the top, and the triangle is on top of that because that is getting drawn last. And so if they were to overlap, the triangle would be on top of the ellipse and the ellipse would be on top of the rectangle, just because of the order that we wrote this code in. Okay, so let's get this looking a little bit like we did for the example. So no stroke, and definitely want fill, right? And we want our rectangle to be red. Cool. So if I want my ellipse to be green, I need to make another call to fill. And this time we're going to color it green. All right. And then if I want my triangle to be blue, I need to make another call that says turn this triangle blue. Okay. And so now we're back to our original picture that we had in the beginning. Maybe I can even make it full screen and it will look a lot like it did in the very beginning. So that's 3 shapes, 4 colors. Now that you've had a chance to kind of dip your toe into the ocean of possibility that processing can offer you, I encourage you to go and play around with changing the placement, the location, the dimensions, and the color of all of your shapes here, and the background, maybe the colors of the background. And then tune into the next video where we look at how to spice this up even more.